By the time we're done, you will have every possible type of LCA in one place, as illustrated by PG&E's mascot helmet. So if you imagine that this image of helmet is the perfect life cycle assessment, we can see every pixel, every color, we know everything about helmet, we can zoom in as much as we want and get details about it. As I just showed you in the last slide, we know that it's impossible to ever get a perfect life cycle assessment. You can't capture everything, you run out of time. By the time you have measured things, it's changed, the system is different. It's just not possible. So we'll give up on that right now. But what can we do to get as close as possible to the perfect helmet? Let's discuss those methods. So what I showed you with the t-shirt slide is what's called traditional process LCA. And the problem is that you get an incomplete helmet. So where you decide to go in and take measurements, you get a very crisp picture that you can zoom in on, but there are pieces of helmet that are missing. There's the overhead, the machinery, the chemicals that I showed before, for example. On the other end of the spectrum is what's called economic input-output life cycle assessment, and this gives you a fuzzy helmet. So the idea of EIO, or economic input-output assessment, is that you take economic data on how much every industry sector spends on every other industry sector, and this allows you to trace the flow of money throughout a supply chain. So you know, I'm spending money on PG&E, PG&E is spending money on poles are spending money on chemicals are spending money on machinery, and so on and so on. And you get a complete infinite supply chain, and when you layer on top of that environmental data from the EPA, for example, you can trace how money flowing through a supply chain leads to emissions or water use or toxics or anything you want throughout a supply chain. The reason it's a fuzzy helmet is because it's only based on industry sectors. So I can look up furniture, but I can't look up wood furniture from a specific supplier, for example. One of them is what's called hybrid bottom-up. And the way this works is you start with the process LCA approach. So right now they should look exactly the same to you. And then you fill in holes using this kind of fuzzy data. The reason it's still not a complete picture is that you still have to make guesses about what you think your holes are. So you might do an assessment of a computer and say, oh, I left out the battery. I'll go get industry data for a battery and plug it in. But you don't know everything that you've left out, so you still can't make a complete picture. On the other end of the spectrum is hybrid top-down, where you start with the fuzzy picture and then you fill in details where you think it's important. So you will see helmet's face become more clear in this picture. So we've decided, you know, the foot isn't so important, the shoe isn't important, the hand isn't important, but let's go get more details on the face. We feel that hybrid top-down is the best approach, and there are numerous academics and literature papers that support this notion that this is the best method to use. So at Climate Earth, we do a hybrid top-down LCA that starts with financial data from a company. This is supposed to represent a general ledger or a trial balance or a profit and loss statement that tells us everything that a company spends money on. And it's a great first place to start rather than going in and trying to ask these questions like we did with the t-shirt of what's important and what kind of materials are you buying. It's all nicely organized in a single place. We know everything that's being purchased, and it's an easy place for us to start. We can pull out how much fuel you're buying, for example. And then we can say, okay, we know you're buying fuel. Do you have other details on gallons or therms that we can use to calculate exact emissions from those types of fuels? And what this method does that other methods miss is, besides burning fuel having emissions, there's also the extraction and the processing and the transportation of the fuel to your site that all have emissions. So we include that with this greenhouse gas factor, kilogram CO2 equivalent per dollar that you've spent on your fuel. And you can see that's a scope 3 because it's something that you're buying. We can also see that you're buying electricity, so this would be very relevant for all of the PG&E suppliers that are here. We'll see how much electricity you're buying, and then we can go in and use either collect kilowatt hour data and then use some kind of a regional electricity factor or general electricity factor just to come up with kind of an estimate of your greenhouse gas emissions. And then the bulk of the analysis is looking into your financial statement and seeing where you're spending money on materials and services, and then mapping that through our database of greenhouse gas emissions per dollar to come up with estimates of the greenhouse gas emissions across a supply chain. And this is how we start. So this is how we come up with kind of a quick hotspots analysis of what is or isn't important, and if we see that, for example, fabric or insurance is the biggest part of your footprint, then we would go to your fabric provider and collect more information and refine our results. To be clear about the project that we're doing with PG&E, the goal is the Scope 3 portion of this. So PG&E has already done a lot of work on their Scope 1 and 2, and our goal is to fill in the Scope 3 piece of that.